I didn't start with satellites. I started with poems and proofs. Early on in high school in northeast Wisconsin, I was pulled, almost evenly, by two kinds of beauty. Poetry, because it can capture a human experience so precisely that it crosses time intact. One mind handing an image to another mind through language. I'd read T.S. Eliot, H.D. Homer, poets separated by centuries, and still feel that strange intimacy of seeing the world the way they saw it. It was like opening a window into history, but not the history of dates and treaties. History as lived texture. At the same time, I was drawn to mathematics for almost the opposite reason. The formalism, the precision, the clarity. And then the way, inside that clarity, there are still mysteries, equations that are clean and uncompromising yet point to something you can't fully hold. I studied Euclid, I read Alfred North Whitehead, and I felt then a different kind of awe. Not from looking through a window, but the awe of wielding an instrument. Something that can cut through the confusion, even chaos, of human events. My first real attempt to bring these two worlds together was through philosophy, during my first year at Oberlin College. Philosophy felt like it might be the bridge, a formal system for conceptualizing history and human change. Hegel's dialectic, Kant's ideas about progress in society, the way political philosophy talks about democracy and peace, and then the links to psychoanalysis, which offered a totally different toolkit for modeling human relations. It was beautiful in its own way. But as I stayed with it, I kept running into a problem. It could feel too abstract. It didn't always touch the ground. I missed that connection to lived experience, the thing poetry gave me so effortlessly. So I went looking for that missing contact with reality at Oberlin, and I found it in history. History was where the raw material lived. Historians work with the notebooks of a diplomat, the diaries of everyday people, the official record, and they try to make coherent sense out of a world that never arrives pre-labeled. I spent the last 2 years of my time at Oberlin immersed in it. Ancient to modern, popular history and world history. The history of the powerful and the history of the weak. It felt like I'd finally found a way to keep my hands on human life as it actually unfolds. And then, writing my thesis, I hit the wall that historians have to live with. My project was on the introduction, or more precisely, the lack of introduction of military conscription in Northern Ireland during World War II. I went to the archives in Belfast, and I did what you do. I tried to learn as much as I could while I was there. I tried to move through an overwhelming volume of material, letters, memoranda, official documents, page after page after page, and the deeper I got, the more a hard question started to press on me. How do I know I'm seeing what's true? When I draw conclusions from what I've read, are those conclusions anchored in something deeper than my own pattern-finding instincts? Or am I just watching my cognitive biases turn a sprawling reality into a story that happens to fit the shape of my mind? That tension stayed with me. It wasn't a rejection of history. It was the opposite. I cared too much about getting it right to ignore the fact that I had no transparent way to quantify how strong my evidence really was, or how fragile my inference might be. So, when I started thinking about graduate school, I found myself hungry for methods that could make the inferential process more explicit, more accountable. The quantitative realm felt, in some ways, more sure. Not because numbers are magic, but because there's a culture of disclosure. Assumptions are written down. Uncertainty is quantified. Evidence has a grammar. At Harvard, in the Department of Government, I dove into that world. I worked on text analysis methods for studying social and political processes, with Gary King, for example, and on statistical methodology for improved inference with coarse. It was exciting. There was something deeply compelling about taking the raw material of the human species unfolding and running it through the machine of quantitative inference, trying to connect dots in a way that was legible, testable, and reproducible. But as I wrapped up my PhD, another dissatisfaction crept in. The scope and scale of quantitative analysis often felt compressed by what our datasets could accommodate. A survey might only include a handful of questions about each place. Cross-national data might have wildly different kinds of evidence available from country to country. Entire dimensions of reality would be missing, not because they didn't matter, but because we didn't have them in the spreadsheet. Our view of history, in a strange way, was being squeezed through the narrowest point of what had been measured. So my mind was open, really open, to doing something differently. That openness mattered, because it's what let me hear the signal when it arrived in the form of a person. Adel Daoud was a postdoc at Harvard and a student in my class, and we became friends the way you often do in academia, through questions. He would come to section religiously. He always asked great questions, sharp, curious, precise questions that got to the heart of things. We talked a lot. Over time, he told me more about his work, and I found myself pulled in by the boldness of it. He was using satellite data to try to better understand the relative effects of Chinese and World Bank activity in development contexts, especially across the African continent. What struck me wasn't just a topic, it was a scale. This wasn't a few villages or one country with decent survey infrastructure. This was a continental analysis of neighborhoods using a data stream that didn't care where a border happened to be drawn. I hadn't worked much with satellite imagery before, though I'd seen friends at Harvard use remote sensing to study ecosystem change across scales, from the field level to forests and beyond. Still, this felt like a different doorway. It suggested a way out of the spatial and temporal narrowness that had been bothering me. Around that time, I was offered a position at the University of Texas at Austin, but I wanted to defer it by a year so I could work with Adele and develop some new ideas together. We didn't have all the details yet. We didn't have a clean framework yet, but we had a direction: satellite imagery, causal inference, and the possibility that the two together could become something more than a novelty. So I left Harvard during COVID and came to Sweden in 2021. That period is still vivid to me. Every month I'd move from one apartment to another. I'd take long walks through the Swedish countryside. Crystal lakes, rocky coastline vistas, islands, forests. I was learning the culture, learning the pace of things, and all the while I was trying to visualize what this research could become. What really could we do with satellite imagery and causal inference? The first idea was straightforward, almost obvious once you see it. Use satellite images as contextual sensors, proxies for confounders. But what made that idea feel new to me was the way I started to understand what satellite imagery actually is. It isn't just a single snapshot. It's actually a dynamic mosaic across time, a macroscopic record of place, containing in high-dimensional form traces of the history of nearly everywhere on Earth. And unlike the kinds of data I'd worked with before, surveys, administrative records, even text, satellite imagery is relevant to almost any study that has a geolocation. It's there, waiting, whether you planned for it or not. That was super powerful to me. So our first work took shape, using satellite data to proxy for confounders in a causal inference pipeline. We studied 8 interventions in Nigeria. We used satellite images to predict which places would get aid, compared to those that wouldn't. It was exciting, concretely exciting, because it showed that this planetary data stream could plug into the logic of causal inference in a way that made sense. But even while we were doing it, I kept hearing another question in my head. How can we not just ask the same question in a new way? How can we ask a new question? That's the kind of question that doesn't resolve itself at a desk. For me, it resolved itself on those walks, out by the Swedish coast, looking at rock and water and wind, thinking in long arcs. I started playing a little thought experiment with myself. Imagine a spacefaring civilization. Imagine you're Star Trek. What kinds of sensors do you have? What kinds of magical tools have become technology? What information would you rely on to understand the causal structure of a world? I kept coming back to this. Images aren't only useful for adjusting away bias. They might also be useful for understanding the response to things, treatments, interventions, actions. Wouldn't it be cool if we could take a satellite image and use that image to contextualize a person in an experiment? Or a group of people in a village? Wouldn't it be cool if we could use that context to supercharge an RCT or even an observational study? Not by changing the treatment, but by better understanding why the treatment works differently across settings. That's heterogeneity. That's the lived texture of causality. The thing that, in history, you feel immediately. Of course, different places respond differently. But in quantitative work often gets flattened. So we started a second series of investigations. Using image information not as a proxy for confounders this time, but as a proxy for the reasons one person responds one way and another person responds another way. The thing I'd always loved about history was that vibrant sense of lived experience. The satellite image at least captures some of that. It's not total, it's not perfect, but it captures more of that lived context than almost any other data source I could think of. And then we ran into the next friction point. We could estimate effect heterogeneity, sure. We could simulate, sure. But were the results solid? How good were these planetary causal inference models in practice? And how should we decide what context matters? A question that kept getting sharper was about resolution. When you try to proxy lived experience, where should you look? Is the broader signal, the regional, the infrastructural, the ecological, what really matters? Or is the zoomed-in, local, near-household information more salient for how responses operate in nature? Those questions became even more salient when I started working with Warren, a talented undergraduate researcher at Harvard. At first, our project was oriented around something else entirely. We wanted to study how the heterogeneity signal changes as we perturb privacy protections in the analysis. We had great RCT data from Peru and from Honduras, And we were curious, if we use satellite imagery, is the signal faithful and robust as we introduce privacy-preserving perturbations? Or does it fall apart? And then, one day, Warren came to me reporting on a conversation he'd had with another faculty member, and he made an offhand remark. What if we concatenate the features from the big scale and the small scale? It was simple, and the simplest ideas are often the most powerful. We decided to run with it, really test it, and it worked. This multi-scale idea, taking features from the local scale and concatenating them with features from a broader scale, turned out to be both simple and effective. It wasn't fragile. It wasn't tied to one special dataset or one special modeling choice. It could be applied across datasets, across models, across contexts. Around the same time, we were learning about work on rank average treatment effect, rate estimates, rate ratios, that give you a way of quantifying how much heterogeneity signal is actually present in a given data and model combination. That mattered because it let us move beyond "this looks interesting" into "we can measure the gain." So we used rate ratios to quantify the benefit of the multiscale concatenation approach relative to other approaches in the literature. And that's when something shifted for me. Planetary causal inference started to feel less like a proof of concept and more like a genuine way of doing what we hoped could be a new kind of science, something that could squeeze more juice out of existing analyses. Yes, but also something that might let us ask and answer genuinely new questions across social, economic, environmental, and even geophysical settings, even natural experiments. If you broaden your mind far enough, might the logic still hold? That's the arc that brought me to the current manifestation of planetary causal inference. Today, PCI is my attempt, with this great team, to finally synthesize the thread that started, for me, with poetry and mathematics. It's a way of taking the lived experience I found so compelling in poetry and history, place, context, texture, the sense that the world is not interchangeable across space or time, and unifying it with the quantitative rigor I learned in statistics and computer science. The mission is simple to say and hard to do. Causal insight at planetary scale. Indeed, traditional surveys and national statistics are costly, slow, and spatially coarse, which limits our ability to diagnose and evaluate policies where they matter most. PCI aims to unify Earth observation data with randomized and quasi-experimental studies, aligning high-resolution satellite imagery with localized RCTs and field studies, so we can identify causal processes across scales, linking pixel-level changes to human outcomes on the ground. And it can't just be clever, it has to be reliable. Just as flight only matters when it's safe, causal insights only matter when they're reproducible. That's why we focus on methods, software, and data pipelines. Why benchmarking and transparency matter. Why open source tools matter. Why ethical data use and respect for local contexts aren't side constraints but core constraints. This is interdisciplinary by necessity. Statisticians, computer scientists, geographers, social scientists. Because nature doesn't care how departments are organized. If I had to name what I was chasing all along, it's just this. A way to move from the household to the village, to the region, to the globe, without losing the human texture, and without losing the inferential discipline. That's planetary causal inference as I understand it now. A bridge between the intimate texture of the particular and the rigorous clarity of the universal. Between what it feels like to embody a place in history and what it takes to make a claim about cause and effect that can survive contact with reality closer to as it is, not just how our data sets reconstruct it to be.